This is a video of the merry-go-round in trigonometry. So Jane sits at the end of a circular merry-go-round. It has a radius of 20 meters. The center of the merry-go-round is 30 meters from a straight wall shown in the diagram below. The point labeled start on the figure represents Jane's location when the merry-go-round starts. This view is from directly above the merry-go-round. What's the shortest distance between Jane and wall when the merry-go-round starts? So here's the starting position. You want this perpendicular distance right here, which is 30 meters. What's the closest distance Jane is to the wall? That would be down here. So you want to do 30 minus 20. So 30 minus the radius, which is 20, is 10 meters. And what's the furthest distance Jane is from the wall? It's 30 plus the radius 20, which would be 50 meters up here. So the answer is A is 30 meters, B is 10 meters, C is 50 meters. In the same problem situation, and then from the start point, the merry-go-round rotates counterclockwise 75 degrees to point A. How far is Jane from the wall? Round your answer to the nearest hundredth of a meter. So you want to do 30 plus 20, 75. And I already have something in there. So if I put 75, I get 49.32 meters. And then what other degree of rotation from the start point results in Jane being the same distance from the wall is the 75-degree rotation? That would be right here. This angle right here, if I extended this radius to a diameter, and then this angle up to here would be 75. So 180 minus 75 is 105. You can check that on the calculator. I'll put 105 degrees in here. I get the same distance. All right, then problem 3. Jane starts at the end in the same 20 and 30 meters, but this time you rotate 60 degrees. And then if you wanted to find each height, you do 30 plus 20 sine of 60 degrees, or in radians 65 or 180. This input box is in radians. So the other thing I could do is 30 plus 20 sine of 60 is 47. And then I keep adding 60. So 120 in degrees, same as radians, 47.302. And then 180 degrees is 30. And at D, it would be 60 more, which would be 240, which is 12, and then 300. 12 again, and then all the way around, be 60. We'll be back at 30. So if I wanted to graph the situation, the maximum, draw a dashed horizontal line at the maximum 50, and then the minimum 10, and then the center line. And so at time 0, or at the start, I'm at 30 meters, and then at F, I'm at 30 meters. At C, I'm 30 meters. Then halfway between A and B, I'm at a maximum. Halfway between E and D, a minimum. And then I could try to plot. A is 47, about 47. B is about 47. D is about 13. And E is about 13. And then draw a smooth curve through there, a sine curve. So So you can see halfway between D and E is the minimum, and halfway between A and B would be the maximum height. And then number 4, you have the same 30 and 20, but now you have that it rotates, makes one rotation every 40 seconds. So from the start, the furthest point away from the wall, that'll be 1/4 way around, or 1/4 of 40 is 10 seconds. And then over here, our closest to the wall is down here. So 3/4 of the way around. 3/4 of 40 is 30 seconds. And then write the equation for the problem situation using rotation in degrees per second. So distance is 30 plus 20 sine 360 over 40 t, or if I simplify that, d equal 30 plus 20 sine of 9t. Or the merry-go-round is rotating 9 degrees per second. And then at 21, plug in a 21 for t. So on the calculator, 30 plus 20 sine 9 times 21 is 26.87 meters. And then if I were to draw a graph of this, so let's use the line segment tool here. I'll draw a y-axis and an x-axis. Try to do that a little bit better. All right, and then bottom here. So you get a text box here. This can be time in seconds. And over here, this is distance. This is from the wall in meters. If I were to title this whole graph, is merry-go-round. All right, so going to 40 seconds. I go on here, 1, 2, 3, 4, 5. So 15 into 40. Goes about 2.5. I'm not going to make this a scale in 2.5, but so let's see if this works here. If I make this 3, let's see. Six, and then this would be 9. So every other check mark, add 6, 15, 21, and 6 is 27, and 6. Let's see here. put these in the right place. And 27 and 6 is 33. And 6 is 39. So that's not too bad there. So scale 3 on the X, and then on the Y, your maximum is going to be 50 and minimum 10. So we'll go with scale 5 here, 10, 20, 30, 40, 50, and then make a horizontal max bend and center line. There's a dashed horizontal line here. So maximum 50. And then the minimum is 10. And the center line is 30. So at 0 seconds, you're the maximum here, or center line. And then it says 40 seconds, so right about here. And then at 20 seconds, and then at 10 at a maximum, and 30 is a minimum. So if I label these here, this is 10, 50, this point, 20, 30, and this point is 40, 30. And this minimum point is 30, 10. And at 21 seconds, you're down here, it's 26.87. That's the only dot, or the only point I calculated there. So I want to draw a smooth curve through here, sine curve. And then problem 5. Uh, it looks like 50, 35, and 30 seconds. If I wanted to write the equation using degrees, let me get the equation editor here. DT equals the center line, which is 50, that's 35 sine 360 by 30, and then times t. And if I simplified what's in the parentheses there, t equals 50 plus 35 sine 360 over 30 would be 12. So how many degrees? So 12 degrees per second. That's still on 360 divided by 30. 360 degrees divided by 30 seconds is 12 degrees per second. Or you can look right there. And so what's the distance from the wall at 22 seconds? You want to do 50 plus 35 sine. Oh, let me pick sine right here. Of 12 times 22. And round to the nearest hundredth would be 15.19 meters. And then the graph, the maximum would be 85, minimum 15. And then 30 seconds here. So once again, let's make the scale 3 here. And put these in the right place. And the height, the minimum is 15 and the maximum 85. So see if this works here. It barely fits. Oop. All right, so 85 would be up here at the very top. And then 50 minus 35 is 15. I don't know why this turned red. This. All right, this center line is 50. Ugh, I'll make that red. And then the graph blue here. So 0, 50, and 30 seconds, 50, 15, 50, and then 7.5. So 6, 7.5. The maximum, 22.5. Minimum. And try to draw a smooth curve through there. Whoop. So So if I label some of these points here, It'll look like that. And if I did 45, let me see, 39, 39, 45. We'll be back here at 45.50. So you can do the exit card on your own. Here's a little clue of sort of what it would look like. You wanted to go from a minimum of 13 to a maximum of 51, center line 32. At 0, you're at 32. And then 6 seconds, you're at a maximum, 18 seconds minimum, and then 24 seconds back on the center line, 12 seconds on the center line.